to combine those with a common theme. Okay, now we're ready to roll, and I'm really delighted to introduce our panelists. And first, I'm going to introduce Yuestas David, who is a senior research scientist at Toronto Region and Conservation Authority, or TRCA as we know it. He graduated with a Master's of Science degree at York University with a focus on hydrology modeling. He manages research, data analysis, development of tools, frameworks, and guidance documents for climate adaptation with the goal of making the state of the knowledge more accessible to practitioners and decision makers. Yuestas is particularly interested in understanding the hydrological impacts of climate and land use on our local watersheds. That's particularly important here in Toronto because we've got quite a few watersheds running through our city. Yuestas will give us an overview of this current state of knowledge about climate change and how it could play out in the Toronto region. Yuestas, I turn it over to you.
Thank you so much, Philip. I'm going to share my screen. Are you seeing my screen okay?
Looks good.
Excellent. Good afternoon, everyone. Thank you for the invitation, and it's truly a pleasure to be here with all of you today. My name is Yuestas David, Senior Research Scientist, part of the Ecosystem and Climate Science team at TRCA. And today, I'd like to present a bit about the historical and future climate trends, potential impacts of climate change on flooding, and how we can build resilience. So let's first start at the global scale. Here's a photograph of the smokestacks that belong to a huge lumber mill in Longview, Washington. Scientists have attributed human activities such as these since the start of the Industrial Revolution to the increased concentrations of greenhouse gases in our atmosphere. And these gases in our atmosphere trap more of the sun's energy into the Earth's system. And that makes the Earth get warmer and warmer each year. But how much warmer did we actually make the Earth from the Industrial Revolution? This color-coded map shows just how much warmer it got from 1880s to 2020. It's showing you the difference in annual surface temperature from the baseline years of 1951 to 1980. Areas in orange are areas that are warmer than the average versus areas in blue that are cooler. Now notice that in the earlier years, you saw a mix of orange and blue, signaling both warm and cooling years. But towards the end, towards the present years, we're seeing more consecutive years of warming. As a result, the Earth's climate has warmed roughly 1 degree Celsius between 1880 and 2012. Most of it attributable to human activities. The only thing is that we haven't stopped warming yet. The green dots on this graph show the difference between observed global average annual temperature from the baseline period of 1850 to 1900. Notice that the difference is often a positive number on the y-axis since the 1970s, meaning that each year, the average annual global temperature has been more than the baseline average. Now, scientists are starting to consider a possible acceleration in temperature change. Notice that this red dashed line shows that general consistent trend of temperature increase. However, the more recent dots are actually charting on this solid line, indicating a faster change in temperature. This solid black line is actually a climate scenario projection known as SSP2 4.5. We refer to this as a middle of the road projection. We meet some targets, we implement some mitigation policy, but we still miss the mark. And that leaves us warming to about 4 degrees Celsius globally. Now, just in the recent history, looking at the global average temperatures, we realized that since the 1980s, each decade has been warmer than the last, and the warmest years on record have all occurred in the last 10 years since 1880, 2023 having the highest average annual temperature. So, where are we headed? This graph shows on the y-axis, the emissions of greenhouse gases. And on the x-axis, the years, the time. You can see the black in recent history, the amount of emissions, how much they have increased. And this one in particular showing the 2019 emissions value. If we continue in the middle of the road scenario, where we just continue with the current implemented policies, we do flatline the emissions. However, it's not enough to meet the targets that we set out. In 2016, 195 countries and the European Union set a target for the amount of warming we would allow by the end of the century, 2100. They signed the Paris Agreement, a legally binding contract that holds all signatories responsible to have mitigation actions in place to limit the warming of the planet to 2 or 1.5 degrees Celsius by the end of the century. Note that we've already warmed up about 1 degree Celsius. So in order to meet that target of 2 degrees Celsius or 1.5 degrees Celsius, this is the trajectory we need to follow in terms of the amount of greenhouse gas emissions. It's a drastic drop that we need to implement. Now, we did predict that 2025 would be the highest levels. And since then, we need to start dropping these emissions based on the implemented policies. So there is still hope that we could still turn gears and meet our target. But if we keep on with the current implemented policies, it's just not enough. So that was a global picture. But what does that mean regionally? Here's a picture of City of Toronto setting up cooling centers in response to heat waves in 2018. We're already feeling the effects. In order to see what is the projected climate for our region, TRCA has carried out a number of studies to understand how the global climate projections translate or downscale to the regional scale. And there are various methods and sources of downscale climate data that we have summarized for various regions, including York Region, Region of Peel, Durham Region, Niagara Region, and we're actually in conversation with City of Toronto to revisit their climate projections. Just as a reminder, here is our jurisdiction that covers parts of Peel, York, Durham, and all of Toronto. And we've started to use the more recent climate projections to look at throughout our jurisdiction, how does the climate projections change? In terms of annual mean temperatures, for our jurisdiction, when we look at 1971 to 2000 and compare it to 2071 to 2100, we do see a lot of warming. The top row here is an example of that middle of the road climate scenarios where we're implementing a few mitigation policies, but we're hitting that mark. The one below is referred to as the worst case scenario or business as usual, where we don't really implement many policies. And that you see a lot of more warming between 1971 to 2000 when compared to 2071 and 2100 towards the end of the century. So when we look at the first scenario, we actually see a warming of 4 degrees Celsius by the end of the century. Now, we warmed up 1 degree Celsius already. Our climate, the Paris Agreement, we were trying to limit up to 2 degrees Celsius, but we're seeing that for our region, it's going to be about 4 degrees Celsius if we don't make a change. And worst case scenario, it could be even up to 6.5 degrees Celsius increase. Both are higher than the global average. And generally, we find that northern latitude areas would increase by much more than other areas. Now, when we increase these greenhouse gases, we trap more of the sun's energy, leaving the Earth's system. That adds heat. And when we warm up air masses, they increase in capacity to hold moisture. There is the Clausius-Clapeyron relationship, where the atmosphere's capacity to hold water vapor increases by 7% for every 1 degree Celsius increase. So if we're projecting by the end of the century to increase our temperatures by 4 degrees Celsius, anywhere between 2 and 4, then we're increasing our atmospheric capacity to hold moisture by 14 to 28%. Now, that doesn't directly translate to precipitation increase by 14 to 28%, but it does set a good upper limit in knowing the potential for the moisture to be there. So when we look at this graphic that compares precipitation change between 1971 and 2000 and compare it to 2071 and 2100, there is a significant increase in rainfall, total annual rainfall precipitation. Even more so when we look at the more business as usual, no mitigation policies implemented. There's another thing to note is that when we have both additional capacity to hold moisture and additional energy from the sun, that results in the potential of more intense storm, just more rainfall, more precipitation within a given amount of time. And now let's take the scale all the way down to a single climate station in Toronto. So we looked at global, we saw for our jurisdiction how it looks like. But now let's look at a single climate station that has observed values of temperature and precipitation in Toronto and see how much it matches with our global trends. And so some of you may have seen a variation of this image before. They're known as climate stripes, and they were originally developed by Professor Ed Hawkins in the UK. Our research analyst, Samia Caglion, was able to carry out the same analysis for records from a station within the city of Toronto. The top panel compares the average annual temperature for each year, shown as a vertical stripe, to the 20th century average of 1901 to 2000. So if you see blue stripes, they're cooler than the century average. Those years were cooler than the century average. If you see red stripes, those years were warmer than the 20th century average. And you'll note that as we get closer to the present, 2020, you're seeing more consecutive red lines and darker ones as well. Now, similarly, the bottom bar shows a comparison of the total annual precipitation each year, shown in a single stripe, compared to the total average annual precipitation between 1901 and 2000. Brown lines indicate that those years were drier than the 20th century average, and green lines indicate that they are wetter. Now, it's more complicated for precipitation because a region could have more rainfall, but it may not be captured by that single climate station. The rainfall could have occurred just outside of that climate station. Nevertheless, we do see that trend of more intense or more increased total annual precipitation. And I think we've all witnessed within our lifespan multiple times flooding as a result of this increased precipitation. Here's a picture of flooding in Toronto during the August 8, 2018 storm. Was roughly 64 millimeters of rainfall. Before we can talk about flooding in urban areas, we have to understand a little bit about urban hydrology. Generally, when a rainfall event occurs, you have a little bit of rain starting off, and there's a bit of a peak in terms of the amount of rain that's falling, and then it slowly tapers off. If you look at a natural landscape that has a lot of potential to soak up most of the rain, from the start of the rainfall event. The line that shows the amount of runoff, the amount of water leaving that site, is minimal, and the peak is much lower. The amount of volume, which is the area under the curve, is very little compared to if you pave all those surfaces like we would in an urbanized area. You see that the result of the flow or the amount of rainfall running off of those surfaces is much of a flashier response. It has such a high peak flow rate. And we were just chatting right before it started how there's erosions in certain places just after the rainfall event last week. That's because there's a lot of water coming in to a certain location all at once. And the area under the curve signals the amount of water, the volume of water as a result of this rainfall event reaching our streams. Now, what we knew, this is bad news. And as a result, we really started implementing stormwater management ponds and control structures to have a criteria that it will reduce the peak flow, the flow or the speed at which the water enters our streams. We would reduce it by capturing it in stormwater ponds like these and letting it sit there and slowly releasing that water. What we realized is that while it does a great job reducing the peak flow, the maximum flow rate leaving that site and entering our streams, it doesn't really reduce the volume of water. There's still a big difference between the amount of volume that we would have leaving a natural site versus an urbanized site with stormwater control. And so here is the opportunity for putting in low impact developments where we try to mimic the natural hydrological process. And naturally, a pervious surface that has the capacity to hold a lot of this rain in the soil can retain up to 90% of its annual rainfall. And so, what if we try to mimic that? What if instead of trying to route the rainfall as quickly as possible away from property and lives, because there's a liability issue, what if we added more storage where the rainfall hits the surface? We call this at source control. And that's the part where we could reduce the volume as well and really help to return to a natural hydrological cycle. When we talk about flooding, there are numerous ones that I just mentioned here, four main ones. It could be riverine flooding, where we have the river carrying the water, really surpassing the banks and toppling over onto properties on the other side of the banks. We can have coastal flooding, where the water level is higher, becomes higher due to certain reasons and entering homes. We can have urban overland flooding. Now, we have prioritized that we remove this water as quickly as possible away from properties and people. But if we have a lot of rain and that's happening in a wide area, that stormwater system it's not going to have the capacity to do that. And so it backs up. And that's why we have urban flooding. There's nowhere for the water to enter because the pipes and the systems are just too full. And finally, we can have groundwater flooding, where due to a lot of precipitation, the water table rises above your basement. And because the water has nowhere to go, it finds the least place of least resistance, which could be through the cracks and windowsills of your foundation. The consequences of flooding, as we know, is quite expensive. In 2013, it cost us 850 million, 2009, 228, 2005 flooding, 671 million, and those are just the identified insurable costs. We know that the damages surpass these numbers. So when we think about mitigating climate impacts on flooding, we have to go all the way back and consider the whole stormwater infrastructure system from the catch basins that receive the water from our impervious areas, to the pipes and how they are routed to these stormwater ponds that do a great job in reducing the peak flows and hold the water, to the outfalls into the rivers. And once the rivers receive the water, they're still part of the conveyance structure. They still have to get that water to the lake. And our streams and rivers cross a lot of our infrastructure, including roads. And so these crossings we call culverts are very important, because if there is blockage here, if the water level rises above, then we're going to have flooding on this road, but also water backing up upstream to urban areas, and it could affect properties as well. Now, one important thing to note is currently we size and design this infrastructure based on extreme events from our historical record, the past 30 years, and we continually update it based on the most recent data that we have from these rainfall gauges. However, if we anticipate an acceleration of climate change and we want to think about resiliency for the future, we have to consider climate change into our infrastructure design. So typically now we would, when sizing this infrastructure, we would look at the 30-year historical record of extreme events. And these graphs are instrumental in our design. We call them intensity, duration, frequency curves. It's a great way to look at the past 30 years of extreme events in one single graph for different durations of rainfall events, and seeing the differences in intensity, you can call them rainfall depth, versus what is the probability of them occurring every year based on how often they've occurred in the past. So this gray line is an example of the data that we can get from historical record. So as an example, let's look at that 60 millimeter rainfall event. If we follow our line to the 60 millimeter event and follow down to the y-axis, we have the return frequency on the x-axis, and that's roughly 1 in 25 years. So there's a 4% chance that you can have a 60 millimeter event occurring every year. Now, if we consider climate change, and we've just started looking at this, there's no standard procedure yet, and we could really use standardization of this processes, but TRCA has started to do this research. And based on our analysis, this red line depicts the future extreme events. If we were to look at that same 60 millimeter event and track it to the red line and follow it down, that has a probability of 1 in 8, as opposed to 1 in 25. So the 1 in 8 means that 60 millimeter rainfall event has higher probability to occur every single year. And so we need to consider this in our infrastructure, which is what we did with Durham region of Durham. We, as I mentioned, these crossings play an important role in the whole stormwater infrastructure. It's almost the last piece of getting the water out to our lake. And these crossings are depicted as dots in our jurisdiction of Durham region. Any dots or crossings or culverts colored in green, they pass their design criteria for both the current and future climate, which is a great news, which means we already have some resiliency in our system. The red dots do not even pass for current climate criteria, and the yellow and orange crossings pass for current, but they're not ready to pass for the future climate. And so this helps municipalities prioritize areas where they need to consider upgrades. Now, this is just a screening methodology. Then they need to go and visit each single culvert and identify why they're not passing, and then prioritize as a result of that. Even if we do screen certain areas and say they're at risk, it's not always possible to upgrade or make these culverts bigger. And that's because there might be constraints on the landscape. It might be very expensive. And so that's why we're also looking through our watershed planning. This is the Humber River Watershed Plan. of the impact of low impact developments, as I mentioned before, trying to renew the natural hydrology of areas by capturing and retaining 90% of the rainfall over the year. If we're able to do that, even in urban areas, what is the impact on downstream flows? Would we still have those flooding, or would those be minimized comparative to what we have now? So I'm very excited to see the results of this study and be happy to come back and present on that study. Now, finally, those were all quantitative methods of looking at climate risk and how do we mitigate climate change for flooding. But there are also very valuable qualitative assessments, including vulnerability assessments and impact modeling. An example here is the Rexdale SNAP, the Sustainable Neighborhood Action Program. That's part of TRCA that finds communities that are vulnerable for various reasons and works with those communities to impact change. And so we looked at the climate projections, particularly for this community, and came up with a total of 32 strategies to deal with both extreme precipitation and temperature. In conclusion, climate has changed and continues to change. Human activities have increased greenhouse gases in the atmosphere, trapping energy from escaping and warming the planet. We are on track to surpass warming above 2 degrees Celsius, and it can be more for certain regions. Additional energy increases the moisture holding capacity of our atmosphere, increasing annual precipitation and the severity of storms. Mitigating climate impacts on flooding requires consideration of climate projections during infrastructure planning and a watershed perspective, low impact development methods, and understanding vulnerabilities can add resilience to climate change impacts. Thank you, and I have my contact email address there if you'd like to chat more. Thank you for your time.
Philip, you're muted.
Philip, you're muted.
Thanks very much, Yuestas. I think it's terrific that TRCA has been able to take some global modeling and technology done elsewhere and apply it to the Toronto region. That's really a thorough presentation. Thank you very much. I'd now like to introduce David T. Macleod. Dave is the Senior Environmental Specialist in the Environment and Climate Division of the City of Toronto, and his work focuses on helping Toronto's government, residents, institutions, and businesses become more resilient to extreme weather associated with climate change. As a pioneer in the field of climate adaptation, in 2007, he initiated climate change on infrastructure and within other sectors such as electricity and food systems. Dave's work has led to some of the world's first municipal climate-related financial disclosures. Dave, why don't you take it away and
Sure.
about how we can be more resilient to extreme weather.
Great. Thanks very much, Philip, and the opportunity to speak to your members. Linking this to ecology, the concept of resilience was looked at from a systems perspective by Buzz Holling in the 70s and 80s. And thinking about biodiversity and systems of systems, I kind of translated some of that thinking towards looking at urban systems. City resilience is described as the capacity of cities to function so that people living and working in cities, particularly the poor and the vulnerable, survive and thrive no matter what stresses or shocks they encounter. So I work for the City of Toronto's Environment and Climate Division, and I've been doing that since 2003. So today, from an overview perspective, I'm going to be talking about local physical climate risks, risks to our people, risks to our infrastructure, some of the things that residents can do, and some actions that government is taking. So I wanted to be really clear about the two forms of action to address climate change. One is greenhouse gas reduction, and the other is climate resilience actions. And I coined this diagram back in 2007 to show that there's actually a sweet spot in between, and often that involves nature or greenness. And I thought I would use this diagram for the Toronto field naturalist because we see that increasing the tree canopy in the middle, healthy green spaces, green roofs, and local food. These are things that can both reduce greenhouse gases and increase our resilience. So down at the bottom of the slide, we see mitigation and adaptation. Those are terms, sort of technical terms, but I usually just say greenhouse gas reduction and climate adaptation or climate resilience. Uh, Looking at our urban systems, we have many forms of infrastructure that look after us and give us a higher quality of life. And I've been involved in understanding the risks and interdependencies of these systems. And as you can see, we've got on the bottom right the natural environment. Just part of my background, my dad was a fisheries biologist, and he worked on the whole concept of no net loss in the Fisheries Act, and we recognize that humanity depends upon a healthy natural ecosystem, and the biodiversity of that ecosystem will help us. We don't know what all the species are even. We're finding new species, we're losing species. Um, and in the midst of all this complexity, we have interdependencies of infrastructure systems. Just yesterday, my internet wasn't working very well. And you can just imagine, remember the Rogers debacle? Well, I mean, imagine if the power's out for a long time, how many systems will fail. So the City of Toronto runs many aspects of our infrastructure, but there's others that we don't. And so I've been working on trying to understand these interdependencies. This is an example of the Finch washout that occurred in 2005. This was a washout of a significant arterial road, and it was actually damaged by a huge storm, and the culvert was not large enough. And I want to link to some of the stuff that Eustace was saying. And back then, we were not paying as much attention to extreme weather. And now our transportation services department is definitely paying a lot more attention. And we've got people out inspecting culverts. And I just want to say, if you're out for a hike and you see a culvert that's blocked, don't try to unblock it yourself. Rather call 311 and report it. And we have crews that will try to clear those out. And by the way, if there's a storm coming, they will go out as a matter of fact to check that those culverts are in good shape. And we have a program also to upsize the culverts as we get money to do that. But you can see here two high pressure gas mains. Those are 16-inch lines, and they must have been very well engineered because those didn't break. And but the amount of disruption for 14 months of people that would have been traveling to work or play or to school was huge. And so this is an example of simple infrastructure, but highly interdependent because we have so many, the Bell Cable, the Toronto Hydro, Rogers, water mains, all going through underneath the road. So some of the key risks in Toronto that we've got, I'm going to say from a health and safety perspective, number one is heat. Okay, so number two is flooding. So Eustace primarily covered flooding, and that has to do with property damage. And he also gave you some indication of the huge costs involved. Obviously, insurance issues are important in having people have access to insurance. But also we're seeing more incidents of poor air quality. And the connection there is when there is a higher ambient temperature, we get more what we call photochemical smog, because the chemistry of the atmosphere when it's warmer and has sun on it tends to degrade the what's in the atmosphere into things that are more problematic for humans, such as ground level ozone. But we're also seeing more damaging winds, damaging ice storms, and also vector-borne disease. And just a special note, I'm guessing that the Toronto field naturalists are quite aware of Lyme disease. I sprayed myself yesterday on my legs, and I checked myself for ticks. These things can even be active even below zero. I've seen that. People are saying, well, it's above zero. I've seen it below. West Nile virus also. Now, these are kind of direct impacts, but the indirect impacts are power outages, telecom outages, and infrastructure damages. Now, I've put it in a bit of a different font here because in the broader, much wider context of of our situation. Climate-induced conflicts, influence on inflation and migration contributing to a housing shortage. A lot of this traces back to climate change. The Earth is a limited system, and we humans are putting strain on it, and we need to reduce our greenhouse gas footprint. We need to reach those targets, and at the same time, climate adaptation can buy us a little bit more time while we do that. So I want to focus a little bit more on the heat issue. In the 2030s, Toronto could see 29 days a year above 30 degrees Celsius, and in 2021, the heat dome in British Columbia cost 619 deaths, and in British Columbia alone, cost an estimated 12 million in hospital cares. So this is a serious matter. It's not like people are only dying in other countries; they're dying in our own. And in an urban situation with power off, this would be the worst case scenario. And in my view, about half of us live in high-rise buildings, and that's growing. We're tending to grow up, and many of the older buildings that don't even have air conditioning. So heat impacts the elderly and worsens it, especially if people have chronic health conditions such as emphysema, chronic obstructive pulmonary disease, or asthma, or heart condition. And people that are elderly also, they just physiologically, they don't perceive that they are hot, and also they don't sweat as much. So this is a risk as our population ages. And when we think about social isolation, we have newcomers and elderly people, and heat combined with a power outage could be deadly. Now, I added in this little chart here that I was quite shocked to find in the last couple of weeks, and that is that the City of Toronto has the largest number of buildings over 12 stories of any city on the planet, second largest to New York City. That's really shows that we've got an issue. The power goes off, even worse. So that's a key message. And I know that many of the members of the Toronto Field Naturalists probably live in high rises, and I may someday too. So this is something to be thinking about and prepared for. So I've got some slides here, and actually I put these together with grad students of mine. I've taught at U of T, and you'll see I've given credit to some of the students at the bottom that helped work on this. And so identifying your support network, who is in your emergency kit, okay? Not what's in your emergency kit, who. What's your meeting place? Have you talked to your neighbors? These are all ideas, but to be socially connected. And then also, if you're in a position, can you get organized now with a few people to be in a better position to when things happen? So getting supplied, first aid kit, etc. You can see some of that stuff. I've got a crank radio. I always keep batteries, but that's an interesting thing too to have. So maintain your trees. If you're in a house situation, take a look. What could fall on your wires? And I do have a big tree, and someday it's going to fall. And what's an interesting thing too is if you have a house, consider if tree debris damage is actually even covered on your insurance. So if you have a tree that you're concerned about, you can call your arborist or an arborist if it's your own tree, or if it's on city property, and usually there's 10 or 15 feet out front that could be city property and it's a city tree. They would look after it, and you can call 311 for that. So managing your own home flood risk, and if you're in a condo, okay, or an apartment, some of these things also apply. Not so specifically directly here, but have your basement ever flooded? Has your neighbor's basement ever flooded? Are you in a low-lying area? And so the things you can do include fixing foundation cracks, ensuring the ground slopes away from your house, clearing debris from eaves troughs, that kind of thing, installing a backwater valve. That's there's a subsidy available for that, and that is a valve that ensures that when there's excess water in the sewer, that it doesn't back up to your basement. So preventing and preparing for power loss, I think, is a key thing. I've got a lot of indication on batteries here, but for your flashlight, and for your cell phone. And I mentioned the radio. You may want to have surge protection for sensitive appliances. So during an outage, never use a generator or gas indoors and unplug electronics that can be harmed by the power surge. And it's advised that you turn off your lights and appliances during the power outage because when the power comes back on, you want to reduce the sort of the surge effect. So staying connected. Some people may now have a electric car. I mean, keeping it topped up is a good idea, but if you know there's going to be a storm coming in the next 12 hours or so, just making sure it's topped up, charging your mobile devices, and listening to reliable information sources. I've got some information on that a bit later. During and immediately following an extreme event, the telecom companies ask you to avoid unnecessary electronic communication and use of bandwidth. The issue there is overwhelming the networks with people checking on everybody. And so that means if you don't need to use up bandwidth, then they ask you please not. And if you can observe any new hazards, those can be reported through 111. Excuse me. So rain gardens are a useful thing. You can see up here with the red arrow. That's a downspout off of a house, and you've got the garden that can absorb the water. Cleaning your eaves trough is useful, and if they get plugged up, you might want to consider screens. If you have a rain barrel, that's a good thing, but you got to make sure it's emptied prior to the rainfall. And checking your sump pump is a simple thing of just pulling up on the float switch and seeing if the pump turns on. Pumps do wear out over time and they get old. My neighbor's house basement flooded because their pump got old. You might want to consider a battery backup system if your pump is likely to be in important use if there's a lot of water around. The city's doing things, and we're doing much more tree trimming to reduce storm damage. We're always repairing the roads with potholes, and Toronto Hydro is strengthening the electrical grid. Yuestas already mentioned about the cooling centers. The city has a heat relief strategy. Its main focus is on education and services for vulnerable people, and it sets a role of city staff and resources when we've got a heat situation occurring. So I wanted to also link to what Ellen was saying about Lenore Farrig, and she actually was my teaching assistant in the 80s when I was taking ecology. And here's an example just of a very small little parquet that was made green. And you can see what it was before. It was all just paved. And now there's a little bit of habitat. But what's interesting here is if you look, here's the where the water from the road flows in to provide water for the trees and the shrubs and plants and stuff. So this is some more green infrastructure, and I find these really interesting. These are soil cells, and so this allows someone to put a bike path on top of there and have soil in there, and you can see a spot where they're going to plant a tree right there, okay? And you can see a very successful soil cell. This is somewhere Queen Street, far west in the city, and that's a 13-year-old tree doing really well and with pavement all around it. So this is an example of some green infrastructure. It's obviously expensive to do this, but there's a lot of benefits. Some great success that I'd like to observe. Many of you probably been hiking along the Lake Ontario shoreline, and this erosion structure here is an example, and it's been very, very successful along the Scarborough Bluffs. There's old pictures would have had this completely denuded of vegetation, and now that's stabilizing quite nicely. Linking again to some what Yuestas was saying before, City of Toronto does clear culverts, but we also clear underneath critical bridges. And this is a critical bridge of the main train line going across the Drawn River. And so these fellows are safely removing some of the debris I mean, they've got most of it gone now, but it was really quite piled up. And you can imagine if big logs and stuff got stuck under there and there was a heavy precipitation, then the bridge could be in trouble. So this is the same picture. And up here, well, it's the same area. There's a red arrow showing where where that was taken. Now, some of the best project I think, and it's just so positive, and I'm ending on this because it's so positive. And this is the naturalization of the mouth of the Don River. And there is a Toronto Field Naturalist seminar coming up on in October, and Ken Dion is going to be running that. He's with Waterfront Toronto. But just really quickly, this is going to be a fabulous addition to Toronto with a naturalized area, and it's going to open up a much better way for the water to get out. You can see that it's a very unnatural water course that takes a 90-degree turn. Like rivers don't like doing that. What they want to do is spread out like a delta effect and be able to have some habitat and for people to access the water. So I wanted to just end on that really positive note because this is a great example of three levels of government getting together, thinking about opening up land for people to live, work, and play, and also coping with the future weather that we're going to be having. So this is my last slide, and this is about keeping informed about extreme weather. And these slides will be available, and you can write down any of these connection points. So thanks very much.
Thank you. Thank you very much, Dave. It's really encouraging to know the City of Toronto is thinking about these issues and taking steps to make the region more resilient. We're going to open up the panel for questions from you, the audience. But before we get started, I thought I would ask just a question or two of the two of you and see what you both think. So here's my question to kind of get us started. What do you think should be the key priorities of municipal and provincial government? Each of you works for one level of government. What do we need to do to make, what do governments need to do to make the region more resilient to climate change? And how much of a gap do you think there is right now between what should be done and what is actually being done by governments? Not to put you on the spot, but this is something I think the public would be interested to know your views on that. So, Dave, you want to go first?
Sure. I mean, I'm going to give credit to Toronto Field Naturalist for giving the opportunity to start having the public understand the seriousness of the situation, and that people can do things themselves so that they become less vulnerable themselves. But I also think that the factor of social cohesion is very, very important, and consideration of social equity. We have a lot of people that are living in high rises, probably have no air conditioning, and maybe to some extent socially isolated. So to me, the first thing is making sure people look after each other, and having government facilitate that kind of work. And there's some excellent work that has been happening in St. Jamestown, where NGOs are working to have neighbors check on neighbors and help them understand what they can do during a heat event and a power outage. Now, that's not sort of big infrastructure stuff, but Toronto has already been investing heavily in the reduction of basement flooding, and that's a great thing. We've also been doing a lot of tree planting, tending of trees, but I think that everybody should be trying to maximize the amount of trees in a smart way that aren't going to affect wires or buildings, and to really try to maximize green space. And there will be a conflict between people wanting electric cars and having a place to park them, by the way, and being able to plug them in. That's going to be a problem. Okay,
Right.
we all see that coming, but in terms of what people can do, uh, there's lots, as I've shown you. But in
Yeah.
terms of what government needs to do, I think we do need to emphasize a lot more on promoting green infrastructure and letting nature help us instead of us cutting nature down. And
Mhm.
that means trying to reduce the amount of pavement. And I gave you some examples at the very end. They were very positive. Like we need to have a lot more of that, and it costs money, and people need to understand that's worth doing. And then something that a handful of us are looking at is how can we have the private sector rewarded for investing in this type of thing? And
Mhm.
Mark Carney wrote a book called Values, and I think that our species of humans needs to understand what we really value and what we need to invest in and what's important. And so having a planet that's actually livable for all of us,
Mhm.
including other species, is something that we need to invest in. And it means maybe emphasizing in a different way on where we spend our resources. So that's my initial answer.
Well, that's great. Thanks so much, Dave. And Eustace, how about you? What's your reaction to Dave's comments, and what do you think should be happening at the provincial level?
Yeah, I agree with David that multiple levels of government are doing a lot. Um, but things are changing quickly as well. And so that's why we see it may seem that there's not much done, but the conditions are changing so fast. Um, just how we were developing certain standards to for infrastructure design and how we have updated, we have to completely change that. And so one thing that we can work on is updating those standards and building them into what we already do. Not a whole new process, but just a slight change to consider climate. And another thing that David mentioned is everything I talked about in terms of flood control and climate change. Sometimes it takes on a very engineer discipline, and we are obviously liable, and we need to make sure that we save people's lives. We route that water away, but it is important also to think about nature and to think about the value of nature in and of itself and how we need to integrate that into infrastructure design as well, not just how we benefit from it, but why it's important and why it needs to be there. So there's a whole number of people who look at that at TRCA, and we need to work together on more projects.
Right. Um, what keeps you up at night, was this in terms of, flooding in the Toronto region? What really do you worry about?
For me, it's just how quickly things are changing and how expensive it can be for us to react. Uh, it's uh, it's helpful to know that a lot of municipalities, when we finally accepted climate change not too long ago, right? It wasn't universally accepted. That's not too long ago. So we're making great progress considering that.
Hmm.
And we have focused on generally mitigation approaches, which is very important to make sure we're on the right trajectory. But
Hmm.
we see more and more that municipalities are now looking at adaptation. We know it's going to change regardless of the implementations that we put in, and we have to be ready for it. And there's a lot of interest in adaptation strategies. So it's just how quickly we can implement. And one note is regarding what David said about how expensive green infrastructure, ways of adaptation. I think we need to work together to figure out cheaper options.
Right. Right. Certainly, if we had more during rainstorms, more water going into the ground rather than into the sewer system, that would certainly help. And uh, but we don't really have any regulations on that. Lots of pilot projects, but that's certainly a direction we can go. Um, Ellen, have you had some reactions from the audience? Do you want to moderate some further questions for our
The
panel?
the chat so far has been pretty quiet. I think people are absorbing, a lot of this sobering information. But I just want to take the moment to reinforce what Eustace said about the value of urban nature. I mean, whether you call it green infrastructure, which of course is a good name for it, but you can also call it nature nearby. And I mean, when if I look at this from the perspective of the Toronto field naturalists, we know that Toronto and cities globally, we do need to be dense in the future. In a way, the future of the planet has to be urban, and we do have to grow up. We don't want all our cities to be sprawling across the landscape. That's completely unsustainable. But they also have to be livable for human beings, and that means, for psychic mental health and for physical mental health, people need access to green space nearby. You can't ask people, well, wait until the weekend and you can drive somewhere. That's totally unsustainable. You've got people living in high rises. They don't have backyards. They need good quality green space nearby, and they need to be able to enjoy it. And I think that the proponents of densification often, this aspect is an afterthought. It's too much of an afterthought for them, and I wish we could have more of a conversation. Of course, it's a big grown-up challenge, right, to say both dense and networks of green interspersed. That's a big grown-up challenge. But I think it actually, in Toronto, we the ravines have got us started on that.
Mhm.
And we can build on it. But just to appreciate the full value of it.
Right.
Sorry, a pulpit.
No, that's very useful. I do have another question of Dave, if I could ask, and Yuestas, if you have some comments, please chime in on this. Of course, we all value our trees, and the canopy provides shade during the summertime. How will extreme heat events affect the canopy? How will trees be affected, and the transpiration that occurs and so forth? Or is that something we should worry about, or something that we can take some action on, Dave?
Yeah, and actually, our forestry department, which is within Parks, Forestry Recreation, they are looking at what species of trees would best be suited. And so we look at analogous sort of climates, like something around North Carolina, perhaps, or Ohio, where we look at what's growing well there, and we're suggesting that those sorts of trees would be more preferentially planted. There is a temperature at which different species will actually die, right? If we reach that. Um, I think it's relevant to say that we need to have enough space for the trees, okay?
Mhm.
And that means space for their roots, okay? And so paving over and not giving enough is going to stress the trees. Uh,
Mhm.
my tree I treat like a baby. Uh, I've I've given it. I called an arborist, got them to tell me to do stuff, and I put down. They said, well, for my particular tree, I put down 3 bags of manure every year and inject the roots. And I have a root injector. And anecdotally, well, it was an extreme wind. My neighbors had a twin tree, identical. Okay, but they weren't doing what I was doing, and the top of that tree blew right off and ruined their other tree. They lost 2 trees in one storm. So, I mean, that's only anecdotal, but I mean, people can look after their trees that they have,
Yeah.
um, and and really super value these. And I mean, the trees are the superstars, they're the rock stars uh, in our ecosystem to provide habitat, cooling, and runoff retention. So selection of trees, if people don't have a front yard tree, you can get it for free. And it is suggested the different species that are preferentially going to be doing better than others.
Great. Thanks. That's very helpful. Eustace, just a question about flooding. What things can individuals do in their homes, those who own houses? What can they do to protect against flooding, or to help mitigate flooding when we do have these extreme events? Should we all be converting our driveways to permeable situations, or what would you suggest?
Yeah, great question. the permeable pavers are actually quite expensive, right?
Yeah.
Just for your driveway. But just having pervious surfaces, whether, if you don't pave over your backyard and so forth, that helps. And every little bit of water that's kept away from the storm sewers, it's an added benefit. So whether that's just a rain garden or rain barrels that you're collecting water, it really helps every little bit.
Great, thank you.
Philip, we have a good comment. Susan Aaron notes that the ravines are a large portion of the city, and that they, of course, they have strong slopes, and that a lot of those lands are actually privately owned. So we know that there are something like 30,000 individual landowners who all own little bits of ravine slope, and some of those might be many of them are residences, and some of them are institutions or colleges or hospitals that are on ravine slopes. The point is that caring for those very steep ravine slopes, keeping them well vegetated with native species, and that's a real challenge, and it's a public education challenge, and also, I guess, a funding challenge. I know the City of Toronto has a property owner's guide to ravine management, so a ravine owner's guide, but aside from public education, it's not cheap to maintain your ravine slope, and yeah, it's a really big area where there's public education is still needed. I know there are areas in Bayview Village, for example, where there are owners who have pools up on the tableland, and they drain their private pools down the ravines. Totally illegal, but who's going to catch them? So it's that step beyond awareness that is a challenge for a municipality like City of Toronto. I don't know if you have any comments, but
Yeah, I mean, I talked about values, okay, and being able to help people understand the value of biodiversity on their own lot, and not having a manicured lawn, and looking at the job creation, actually, if people value that, is, having people that are trained master gardeners, landscape architects. I mean, having a slope behind you and having people value that it's healthy and that it's not going to slump away because it's so eroded, right? That's worth something. And there are even companies that specialize in the landscape maintenance of the ravines on the slope, right? They've got special techniques to do that, and yes, it costs. But if people are on a ravine, it's partly a responsibility, but it's also a huge property value issue. If they run it right, people will want to live there, and when they go to move away, they'll get more money for it. And it's been proven that having a tree out front directly adds to the value of your property in tens of thousands of dollars.
Right.
And so having people understand this, and you mentioned, Ellen, about, who's going to know that the water's being drained out of a pool. Well, I actually didn't know that was illegal. Well, now maybe I'll just report that house if I see that, right? And and people have got cameras, they can take a video, and it's like, oh, maybe next year they will do it properly.
Right. We have a question from Gwen Harris. What's to be done about highways? She's thinking about all the runoff that occurs, among other issues, but she's particularly concerned about building new highways unless there is some new technology to allow more permeability of that material that goes on the ground. Any ideas or suggestions on that? Or I should say new streets as well.
Yeah, I helped do the first climate risk assessment for transportation services. That's our roads department. I mean, in our urban area here, what happens is the water just goes down the sewer, okay? But I mean, there have been some cities that have decided to put limiters on the storm sewers intentionally. So they intentionally leave the water on the road a bit. And people just have to manage the expectation that there could be a bit of water on the road. And I guess that's going to have to slow you down, isn't it? But there is such thing as permeable pavement. It does need to be maintained. It does get plugged up over time. On the highways, if you're thinking of Highway 413 or some of the the big development that's on, that sounds like it's going to be happening. I mean, depending on where the runoff is directed, sometimes there are retention ponds and ways to slow the runoff down. But yeah, I mean, it's more paving is more flashy types of hydrology. Eustace, do you have any comments on that?
Just to add that in some new developments, whether it's roads or highways, they are putting in more green infrastructure along the middle or the side of the roads to collect that water and slowly infiltrate it. The Etobicoke Creek infiltration trench is a very good design that collects all that rainwater and slowly infiltrates it in the ground beneath it. So there are already technologies available, stormwater technologies available to reduce that runoff from those surfaces.
So, but you mean the big provincial highway? I mean, that's when the designs are approved, that is the time when all of these low impact development requirements could be put in, and it takes foresight to do that, obviously.
That's very interesting.
I can see a comment in the chat. I can comment directly about it because I walk by it. Steep slopes on Burt Brook Ravine between Sunnybrook Hospital, CNIB Bloorview. Yeah, what's happening there? I've been actually monitoring that, and I've been in touch with TRCA managers about that. Really interesting. One of the rehab hospitals had a great big parking area that sloped down, and it had a really big catch basin, and then had an underground pipe that shot over to the ravine and caused a huge amount of erosion. I've been watching it for 25 years because I go hiking there every few weeks, and massive amount of erosion and about to take out the South Trail. So what they're doing in there, they're spending a lot of money, but it's really needed. They put in a bit of a road, and they're bringing in heavy equipment to stabilize the banks. So it's super needed. And then, I mean, years ago, like 10 years ago, a lot of work was done on Burke Brook to try to bring it back as fish habitat, right? And when you get a lot of erosion happening, this covers up all of the fish eggs and it wrecks it, right? So it's very responsible what TRCA is leading there. So I don't know if Eustace, if you're engaged on that one.
Not that particular project, but these are some of the things that restoration services do. They look at these big projects that they can undertake that's quite needed around the city.
Great, thanks. Sounds like we need more financial incentives for the public to do the right thing. Susan Ayres commented that there are city grants for the maintenance of ravine slopes, but how many people who live on a ravine actually know about those? And she's suggesting that there needs to be more dedicated outreach by probably the Parks Department to get those grants taken up, or maybe they're already taken up. I don't know, Dave, but sounds like we could use some tax incentives both at the municipal and the provincial level to encourage people to do what needs to be done to minimize the damages that would occur that are going to cost a lot of tax money to repair. So they probably would pay for themselves over the long term. Any comments on the financial incentives that we could be using?
Yeah, that one I don't have knowledge on. Sorry.
Okay, that's all right. Eustace, how about you?
In terms of financial incentives, I mean, we could think about just what Dave was mentioning, planting trees in the front yard. It doesn't give you a tax break or whatnot, but it gives you trees and increases property values, right? So it might be just making more homeowners, especially in new subdivisions, right, where there aren't any trees, more aware of these issues as for new homeowners.
Right.
There is the continued talk about the stormwater surcharge idea, the so-called rain tax, which some people refer to it that way disparagingly, but the idea really is that if you have a lot of paved over area, it would make sense going forward for a municipality to charge you on that paved over area. And the way it would pan out on the ground is that if you had a very big parking lot, that produces a lot of stormwater. And if, however, you then, as suppose you owned a big mall, and instead you then said, well, we're going to put a bunch of trees along the edges of that parking lot. We're going to capture the rain on site, let it soak in. Then you would be relieved of that stormwater surcharge. And so it's a way to nudge, let's say, owners of big parking lots to build better parking lots, just as an example. So that's, I think, haven't really been following it closely, but I think that's coming back into City Hall discussion. Is that true?
Yeah, there are consultations that have started up recently about that. Years ago, the idea was rejected, but it's being raised again. Yeah, and it is to incentivize property owners to have less hardscaping or deal with the water on site. And I should say that the Toronto Green Standard does have provisions for new developments to retain a certain amount of the runoff on site.
Mhm. Excellent.
And there are some incentives associated with that. So there is a bit happening in that respect.
Right. We've got a question from Rosie as to whether artificial grass would be classed as a paved over area.
I don't know the answer on that
That's a
one.
real technical question. I don't know. Yuestas, would you have an answer to that one?
If it allows water to infiltrate, then it's pervious. And if it doesn't, if it's artificial and there's nothing allowing the water to infiltrate, then it should be
Right.
paved.
So it probably depends on the type of artificial grass it is and whether it's embedded in porous material that allows the water to go through.
Jane Weninger, a City of Toronto planner, gave us a talk a couple of years ago about green standard policies at the city, and she mentioned the city bylaw for soft landscaping of residential areas. And in that case, that bylaw does, like, if you have artificial grass, that doesn't count as soft landscaping. So they do want real soil and plants, and that's what they would consider.
I think maybe we have time for one last question, and we have one from Margaret Hall. It's a question, I think, for you, Yuestas, and it's, when will the TRCA project for Rockcliffe Riverine Flood Mitigation Project get underway, and will it include the culvert at Scarlet Road? Very specific question.
Very good question, but unfortunately, I don't have the answer to that. You could reach out to our restoration services team, and they have a list of projects underway for the year and planned projects for the future.
That's great. Maybe you can let Ellen and me know what the URL for that would be, and then we can get back to Margaret Hall and let her know how to get the information that she would like to have.
Sure.
Okay, great. Well, I want to thank you both for really an excellent coordinated presentation on climate change and how it will affect the Toronto region. Thank you both very much, and best of luck in your endeavors, and hopefully this panel will move us forward. So take care and have a great weekend. And
Thanks.
goodbye to everybody. Thank you for showing up. And I'm sure everybody's going to want to get out there in that beautiful weather and do some hiking before we get started next week. Okay.
Good stuff.
Okay. Take care.
Thanks, everyone. Bye.
Bye.
Thanks so much, everybody. Take care.